Hi, I'm Dave Kassler, amateur radio operator, KE0OG, here with an Ask Dave video to answer a much asked question, how to make a plain old dipole. We're going to do ours for 40 meters, and of course you need some wire to make it out of, and I have this. The painter took down the solar panels, and this is some of the wiring that had to be moved out of the way. So what we're going to do is harvest this, because it's what we've got. You may have something entirely different. I'm looking for a very inexpensive way to build a perfectly good dipole. Okay, so let's start by untangling this. It's kind of wet and dirty. It's the time of year in Colorado that the Chamber of Commerce never talks about. Around the 1st of July begins what we call the monsoons. And what that means is we might get some sunshine in the morning, but almost certainly we will get some thunderstorms in the evening. So let's take this one that I've got right here. Okay, I'm gonna first just kind of clean it off a little bit. Just so we don't get gunk all over. Now this wire is what's often called Romex, okay, and this happens to be what's called 14-2. So there's two 14 gauge wires in here, one white, one black, and there is a third wire that's a bare copper wire for ground. So there's actually 3 wires in here. So whatever length we get to triple. 19 feet and about 2 inches. Okay, so that means we're going to have 3 pieces of wire 19 feet long. It's not quite going to be enough, because if you add all that up, 19 times 3 is 30, is almost 60. But we're still going to need just a little bit more than that. Now, if you run the formula for the 40 meter band, which is 468 divided by the frequency in megahertz, will give you the length in feet. I know that's not very metric, but that's the way it's been. So the thing we want to do, it works out to about 66 feet. So this will give us just shy of 60 feet just from this one cable here. And then we'll pull some more cable from some of the other wires. Now the question is, how do you get the wire out of the Romex? This is an interesting little knife. This knife right here is designed specifically for splitting Romex. Now, if you cut Romex before you use it in a house, you have to get at the wires that are inside. So this little tool right here is designed to, it's a hook, and it goes in there and it just splits the wire. So now let's see. We only have 20 feet to go. But what you'll find is sometimes this hook will get snagged on what's inside. Let me show you what's inside. There's the Romex, which is lined in paper. Okay, this brown paper, just a little bit like wet paper right now. And then there's the more brown paper around the ground. Okay, and we're going to use all 3 of these wires. Here is a black insulated wire, which, by the way, in electrical systems like your wall outlets, black is positive, not negative. It's positive. It's the hot. And the white is the negative, but more commonly called the neutral. Okay. We're going to put an insulator in the middle, and we're going to feed it with coax without a ballon. Just feed it with coax, because that's the most common way it's done. If we run into problems, then we will add a ballon. So let's just take what we can do and see what we can do without all the fun of, you know, having to run ballons and that sort of thing. Here's an example, by the way, of water getting into cable. Okay, the water has gotten down that far in there just from the wire sitting out in the rain. So let's pull this off. It hasn't taken us too long to do that, has it? Okay, we've got 3 wires. Okay, I just want to get the paper off of that ground wire. Now, what I'm going to do is separate these so that I can, you know, kind of roll them up each separately, and then we'll do the soldering. And what I'm going to do is where the insulator is, I'm going to put this kind of wire so it'll be in the middle, so it'll be real easy to solder to that for our connector. And then at the very end, I'm going to put some more of that bare wire so that when it comes time to shorten or lengthen it, it's easy to do, wrap it back on itself. If you wrap insulated wire back on itself, that's fine, but it doesn't work quite as well. It adds a little bit of capacitance and inductance to the end of the wire. Note the way I'm winding this. I'm not winding it in anything other than a circle because I want that. Okay, so we're just gonna run this like this into a nice little hank of wire. I don't mind working with 14 gauge wire. 12 gauge wire is just stiff. And besides which, 16 gauge wire would do really well here. And for a 100 watt rig, you could probably get by with even 18 gauge. I've got a little picture here of some wire that I saw at Home Depot. Little tiny spool, 250 feet I think it was. And for a very low price, just for getting wire. Plus the wire is thin enough that you could, it's kind of stealthy, which could be very handy in a variety of situations. So here's what we got. We've got almost, not quite, 66 feet. So I'm going to do the same thing with another piece so that we do have up to 60 feet. Or 66 feet, maybe 70 total feet, something like that. So let's go to the next step, shall we? Soldering all this. Now I'm going to take the short, put it in the middle, and we're going to build out from there. Okay, so about the middle is right here. Okay, now. Okay, this is where the insulator is going to go. This is the middle insulator. Now, in the middle insulator, I got these insulators at a Hamfist. They're just little plastic things. This right here is an electric fence insulator, which could be used also. I've made dipoles with electric fence insulators too. You can cut little pieces of PVC pipe or little pieces of plexiglass and so on. There are lots of different ways to do that. Now what I'm going to do with each of these, I'm going to put it on here, okay, with a fair amount of wire sticking out. I'm going to bend back like this, okay, and I'm going to twist. Now we're going to solder that right there. This is going to go down to the connector. Now on the other end, making sure I've got enough room here. Okay, I'm never sure of enough room. Okay, and so we'll just continue turning this. And we'll solder these together. Now, what I want to do now is put the connector. I'm going to use this connector. You don't have to use this connector. This is the little SO239. But I'm going to use this because I'm going to be making a rather lengthy piece of coax to test this plus all those MFJ antennas. So this little thing right here is handy. It's not necessary. You can just solder your coax right to this. But let's go ahead. All right. And we'll put this in my little circuit thing here so we can hold it. Now the first thing that has to be soldered, I'm going to solder anyway, is that center conductor. Now, see, this makes it much easier to solder because it's being held in place and we don't have to worry about that. Now, you can use a regular soldering iron for this, although with a 20 or 30 watt iron you'll have to be awfully patient for this to work. A bigger iron would be a lot easier, plus I'm going to turn the heat up quite a ways here so that it's just really hot. It doesn't take long for that to get hot, but it does take more than just a little bit of time. Now I'm going to go ahead and use my thick solder for this. Let's see how warm it is yet. It's still warming up. 350, 360. This is degrees centigrade. I'm going to go to 400 degrees centigrade, which is quite warm. Okay. Now it actually, the little part of the soldering iron that gets hot is right here, and that's where the temperature is. So you have to wait a moment for that to come out over there, which it has now. Okay. Now, put a little solder to aid the heat transfer. Nope, I'm not done. There. I just saw it go. You can see the solder flowing along the joint. The mechanical strength comes from twisting them together. The electrical connections from the solder. Now, one might ask, since this is out exposed to lightning and all that sort of stuff, don't we need to worry about lightning causing that solder to go away? And the answer is yes, it does. However, your antenna, especially a wire antenna, is not going to survive a lightning strike. Okay, now we have an antenna here. It's not yet 66 feet long. It's close to it. So I think it might be time to measure it and see how much more we have to add. So we get 33 feet on a side. So let's stretch this out in the backyard and see what we got. Okay, so we've got stuff stretched out here. We're going to see how long it is, and then that'll tell us how much more we need to add to each end. The answer is they're a little bit longer than 20 feet, so we have to add a good 13 to 15 feet on either side. And then having done that, we should be about ready to go to try putting it up. This may seem a bit like making a quilt. We're putting all kinds of things together that we already have. This just adds a few feet, and then we're going to see if we can't supplement the rest. I really don't care to deal with solid wire of bare wire, which is in the order of 10 feet long, 20 feet long rather. We're going to split it in half. Yes, this is a royal pain. That ready-made dipole from whoever, MFJ, whatever, sure looking a lot more interesting, isn't it? Okay. And there's pre-made dipoles, which you can get from a bunch of people like DX Engineering and MFJ and a lot of different places. They cost less than $100. And you don't have to splice various and strange lengths of wire together to get something. Okay, we've made 4 joints here that we need to solder. These, by the way, are called linesman's pliers. They're a new addition to my toolkit. That should be all the soldering. Okay. We're going to take the other two of these with us and go back outside, do some more measuring, and see how close we are. I think we may have it this time. If we are, we'll just twist these on tentatively at the 66-foot point, or 33 feet from each end, until they get ready, and then the next step's getting it in the air. Okay, there's the wire coming down right up here and into my lap. And I've got the antenna analyzer right here. Turn it on. Okay. Now, let's take a look here. What we're looking at is 6.2. Let's go up in frequency. We're looking for something around 7. Okay. And we see that the dial, whoa, goes way down low. No reactance at all. 45 ohms at 676 megahertz, which is low. Okay, so that means the antenna is a little too long, and we can shorten it easily by bringing it down and shortening each end. Okay, we're going to go figure out how much to do that. Note that the 45 versus 50 gives a 1.1 SWR. What's our 2-to-1 band here? Okay, there's 2 at 6.9. There's 2 at 6.6. Okay, so there's a very good possibility we might be able to cover very nearly the whole band. Okay, so we have modified the antenna by making it 7 feet shorter. Let's see how badly we screwed up. Okay, we're at 6.75. We're going to go up. Okay, we overachieved. It's resonant at 7.5. Okay, so we're going to go back and give back a couple feet. This is where we're to cut and try. Alright, let's see where we are now. Absolute lowest is 7.3, which is the top of the band. We can go down to 7.1 if we want to. 7.17. Okay, this covers most of the band. I'm going to stop right here with this, and now we'll do some on-the-air tests, because this is close enough. All right. So what did we get out of that exercise? It was a lot of work. What I tried to do was to build a dipole with materials on hand without taking anything new. Now, as it turns out, I had the insulators. I also had the electric fence insulators. Those come pretty cheaply. And I had some Romex that was ready to be recycled, and I thought, well, you know, it's wire. I can use it for an antenna. Found out that it was a great deal of work to do that, but it worked. It worked. And dollars were saved. I didn't go get special antenna wire. I didn't order a dipole, although there were times in there when the temptation to do so was quite strong. We put up the dipole on the antenna test fixture that I put together for the next few videos, and we are going to have some great episodes coming up on these MFJ antennas. So, does the antenna work? Yes. Here's a couple QSO reports. I talked to KG5UEN. It was a brief conversation because his signal was very faint. He answered my CQ, and it was interesting. He was just in the noise, When I switched back and forth between the vertical and the dipole, the signal strength stayed the same, but there was a little bit less noise, maybe 3 dB less noise, on the dipole. So the dipole is the quieter antenna. And then I talked to KK5RT out in Roswell, New Mexico. Imagine he takes a fair amount of ribbing for that address. But we had a great conversation for a long time. It was armchair copy. I mean, we could have been sitting in the same room with each other. It was that good. And we spoke actually for quite a while. And his signal was many dB over 5.9, and the same with mine. Now, I flipped back and forth a little bit to try the vertical antenna, and he said he couldn't tell any difference in the transmit signal, which is good. That's the way it should be. The vertical and the dipole should be about equal in performance. Now, you might ask, one is horizontally polarized, the other is vertically polarized. How can it sound the same at the other end? Well, the great secret is that any propagation that arrives to us via the ionosphere is actually circularly polarized. So you can pick it up equally well on a dipole or vertical. The dipole or vertical, horizontal versus vertical, is really only applied for close-in skywave or ground wave types of things. So it was a success. I made a dipole all by myself using stuff I had around the house, including some rather stiff and awkward Romex, put up an antenna, and it worked. And I'm pretty proud of it, actually. So what I'm going to do now is take that antenna down, and so I can start testing the MFJ antennas. I'm not going to throw it away because it is a good antenna, and I'll keep it in reserve, or maybe I'll use it for a giveaway, if you don't mind sharp edges where the joints were soldered. Thank you so much for listening. Please consider the tip jar and the Patreon page. Please like this video, click on like, also subscribe. And all those things together help other people find these videos on YouTube. And because what you're doing when you do that is that you define your preference. There's a lot of other people who are just like you with the same preferences, and YouTube introduces the video to them too. Thank you so very much for being a great audience. It is so much fun interacting with you. And our next video again will be, unless something else comes up, an MFJ antenna. What it could be is I did order some new audio hardware, new microphone, and to replace the thing I've been dealing with here, which seems to be on the fritz, as you noticed earlier in this video. It's been used for several years. I mean, I've certainly gotten my money out of it, but it is time for a new one. All right. Until we next meet, use both feet when walking, and 73.